All right, so let's check out practice 5.5. And here's the first question. We're given a function 2 sine x, and they want to know what the amplitude is. Well, the amplitude is the number being multiplied to the sine, which is 2. Use the graphing tool to graph 2 sine x and x. All right, so we'll click to enlarge that. We'll choose the sine function there. And we're going to start at the origin since there's no shift. And that's the regular old sine function, period 2 pi, amplitude 1. And let's put on there another sine function that has amplitude of 2. And so there we have it. We've used the graphing tool to graph sine 2 sine of x and sine of x. Determine the amplitude and period of the following function. Okay, well, the amplitude is the number multiplying sine, and the number multiplying sine is 1. And the period. So remember, the period is 2 pi over b. And b in this case is 5. And so the period is 2 pi fifths. And now we'll use the graphing tool to graph this. So we'll choose a sine function. It starts at the origin. Our amplitude is 1. And the period is 2 pi divided by 5. And I have to check really fast. We have to graph sine as well. Use a graphing tool to graph the function. Okay, so the last one they wanted us to graph sine as well. This one only wants us to graph this function. So that should be good. Number 3, determine the amplitude. Well, the amplitude is the number multiplying the sine. That's 4. And the period. Again, the period is 2 pi over b. In this case, they're telling us b is pi. And so we get that the period is 2 radians. And we will graph this function. So we'll choose a sine function. This one starts at the origin. It has an amplitude that's 1. The period here, though, is now 2. Or was the amplitude 1? No, the amplitude is 4. The amplitude's 4 there. Let me just change that. We get an amplitude of 4 and a period of 2. Number 4. Determine the amplitude, period, and phase shift. So notice that this is x minus a number, which means 3 pi over 2 is exactly the phase shift. So first of all, the amplitude, 1 is multiplying the sine function there. 1 times sine. So the amplitude here is 1. The period. Now remember, the period is 2 pi over b. And b here is 1. And so the period is your standard period of a sine function. And the phase shift, since b is 1 here, means the phase shift is exactly this 3 pi divided by 2. Now, for the phase shift, also remember the phase shift is c over b. For our particular problem, c is 3 pi over 2 and b is 1. So we get 3 pi over 2. And then finally, we will graph this. So let me just remember this really fast. We have an amplitude of 1, a period of 2 pi, a shift of 3 pi over 2, phase shift. So let's graph all that. Choose the sine function, and our amplitude is 1, our period is 2 pi, and our vertical shift, there isn't a vertical shift. We're talking about the horizontal shift. The horizontal shift is the phase shift. And 3 pi over 2. And that should be our answer. So, determine the amplitude. Well, the number multiplying sine is 4. That's the amplitude. The period, remember period, is 2 pi over b. And if we look here, b is 3. So the period is 2 pi over 3. The phase shift. Now there's two ways we can go about this. So we have 3x plus 2 pi. One of the ways we can do this is to factor out whatever number's in front of x. In this case, that's 3. And so we'll factor that out. And if you have x plus or minus a number, then this number is the phase shift. 2 pi over 3. Now, the standard form is x minus c. So the standard form here does have a minus sign, but here it's plus, which means this number here must be negative, because a negative times this negative will make this plus. So we know the phase shift here is negative. And we'll use the graphing tool. So let me make sure I got this information here. We got our amplitude is 4. Our period is 2 pi over 3. And our shift is minus 2 pi over 3. So we'll choose the sine function. Starts at the origin. Our amplitude is 4. Our period is 2 pi over 3. There is no vertical shift. That's the D value. Going back to the lecture video, the vertical shift was the D value. The horizontal shift is the B, the one we're doing now, and we got a minus 2 pi over 3. Number 6. Now we got some cosine functions. The amplitude here, the number multiplying cosine is 4. Use the tool to graph. All right, so we got to be a little bit careful now because they only give us a sine function here. So in other words, if I start the sine function at the origin, I get a sine function. We don't want a sine function, no. We want this to be a cosine function. So we're going to have to choose this and shift it. Now we can either start it at minus pi over 2 or pi over 2. You can't do that for it. Starts at okay, whoops. This one right here, the one that kind of looks like a parabola, this is actually the cosine one. There we go. There's a cosine. And all we got to change here is 4. Okay. So apparently they, for whatever reason, they wanted the original cosine function on there. So we're back to that again, even though they stopped doing that for a while. But either way, my answer is correct. I just didn't put in the regular old cosine function there. So little tricky there to know when to do that. I guess it does say, looking at the top here, it does say graph the function and y equals cosine x in the same coordinate system. So it does say that. So our next question, determine the amplitude. So there's 1 is multiplying cosine here. And the period. So remember, period is 2 pi over b. So looking at what we have here, b in this case is 4, and so we'll get pi over 2. And let me just check again. It does not say this time to graph the standard cosine function. And I forgot what we have here. We just have a amplitude is the same, that's 1, and we have a period of pi over 2 for this one. Determine the amplitude and period. Okay, so now we have the number multiplying cosine is -8. And by the way, the minus sign means it flips. So your standard cosine function will look like this. However, so this is cosine. However, if you multiply it by a -1, it flips. Oh, okay, so the amplitude, taking as positive here, I suppose that actually does make sense. The minus sign there flips it. The minus sign really doesn't affect the amplitude at all. So the period, remember period, 2 pi over b, and b in this case is 2/3. So that is 2 pi times 3/2, which gives us 3 pi. And use the graphing tool to graph the function. So it doesn't say graph the original at all. It just says this one, so that's good. We're graphing cosine, so we'll stick it here. And our amplitude we got was 8. Our period, what do we get for the period? 3 pi. And there is no vertical shift, there's no horizontal shift. But the minus sign, when you multiply by a minus sign, that will reflect it over the x-axis. So looking back at my picture on the paper here, here's regular cosine. And then that flips, the minus sign flips it across the x-axis here. So it's pretty common to say that that's a reflection. It reflects over the x-axis. Amplitude, period, and phase. So again, the number multiplying cosine here is just a 1 for this one. The period, remember, period, 2 pi over b. B in this case is 1. the phase shift. Remember, the phase shift is C over B. And we have here x plus pi over 2. Now remember, the standard form is x minus some number. So that means C must be a negative pi over 2 because we have a positive sign there. So that means C must be a negative number. And it wants us to graph it. So let's assert it only wants us to graph this one function. We're graphing cosine. We'll stick it on there. And what do we get for the amplitude? The amplitude is 1. Did we do period on this one? I can't see. Back to the problem. We did. Period is 2 pi. So our period is 2 pi. There's no vertical shift yet. The phase shift is the horizontal shift. So a little unfortunate. They're switching names here, but they do mean the same thing in this case. Phase shift is horizontal shift. And so we have a phase shift of minus pi over 2. And that's everything. Amplitude, period, and phase. So the amplitude is the number multiplying cosine, in this case, 1/3. The period is 2 pi over b. And what do we have for b in this case? We have 2. So the period is pi. The phase shift. Now remember, there's 2 ways to think about phase shift. And so what we have here is a 2x plus pi. Now one way to think about the phase shift, remember it always has to be in the form x minus c. And we can achieve that by factoring out a 2. And when it's in this form, then this is exactly our phase shift. And in this case, that phase shift would be minus pi over 2. Again, remember the form here is x minus a number. So in order to get this positive sign here means C must be a negative number. Now the other way you could do this, they'll both get you the right answer, C over B. Remember that? So if we look at the problem here, C is pi and B is 2. And there is our pi over 2. And again, it is negative. Remember, our standard form is x minus c, but we have a positive sign, which means c must be a negative number. And we'll graph this. So what do we got here? We got an amplitude, 1/3. Our period is pi. Our shift is minus pi over 2. So we'll graph that. Cosine. We have an amplitude of 1/3. Our period is pi. And the phase shift, which is the horizontal shift, is minus pi over 2. Number 11. Here's some vertical shifts now. Use a vertical shift to graph the function. All right. So sine looks like this. That's the part that repeats. So sine of x minus 5 means the whole sine function shifts down 5 units. So we'll graph a sine function, and instead of starting at 0, we'll start it at 5. Oh, I guess just clicking on the graph puts the sine function in there. Now this is a vertical shift. So the D value from the lecture is the vertical shift, and we have a -5. Use a vertical shift to graph the function. Okay, let's just check out really quick what we got here to graph this function correctly. So by looking at our information, we can see the amplitude is 5. That's number multiplying sign. We can see B is a half. There is no C value. And D is 3. So the period, which is 2 pi over B, we have 2 pi over a half, which gives us 4 pi. And because C is 0, means there's no phase shift. There's no horizontal shift. So we're graphing sine. We'll click it in there. And what? It automatically gives the correct amplitude and period. Okay? So all we have to do is enter in the vertical shift. Huh. All right, that's simple enough. They made that seem a lot more complicated than it actually is. And the last one, number 13, find an equation for the graph. Let's zoom in on this, and we can't make that any bigger. There we go. Let's check this out. And I'm going to try to draw it as well here. So we have first of all, we have a sine function. So just to be clear, cosine looks like this. So we do have a sine function, and we can see it goes to 4 and -4, which tells us then our amplitude is 4. So we know so far this is 4 sine of something. Let's check what the period is. If we look at the graph, we see the period is 4 pi. We also know that period is 2 pi over B. And so we can solve for B. And so we know B is a half. And so we have sine of 1/2 x. Now we'll determine if there's a C value, a phase shift, if this is shifted left or right. And if you look at the graph, you can see sine starts right where it should, right here at the origin. So there's no phase shift. So we'd say C equals 0. So there's no phase shift. And now finally, we're going to look to see if the function is moved up or down. And it's not. The sine function intersects at the origin, 0, 0. And you can see that's what's happening on the graph. So the sine function has not been moved up or down at all. At least vertically speaking, it's right where it should be, which means D is 0. So type the equation then that we just found. Well, we got 4 and that should be our answer. And there is practice 5.5.